Good to have you back for another lesson. 1.7 is all about absolute value equations and inequalities. You can see the word inequalities there, and we are going to be using a lot of the skills from 1.6. So hopefully you understood most of what was in that lesson because it will be implemented today. If not, try to follow along, and of course you can always ask questions when we meet. Let's get started. Before we go ahead and look at absolute value equations, let's make sure we understand what absolute value is. Absolute value is the distance from zero. So if I were giving the equation absolute value of x equals 3, I would want to start at the 0 and find out what value would be 3 units away from the 0. So here I move 1, 2, 3, and that would put me at a positive 3. So one of the solutions for sure is 3. And you can tell if you plug in the 3 here that the absolute value of 3 is indeed 3. Now let's also remember that absolute value is always positive. So that's going to be important when I think about the next possibility here. What would happen if I took that 0 value and started at the 0 and I moved 3 units to the left? That would put me at a negative 3. Does that really work? Let's take a look. If I sub in the original equation, that negative 3 in for x, and I know that the absolute value is always positive. Now that negative 3 becomes a positive 3. Did that equation check out? And the answer is yes. So I now know that there's a second answer, and it's negative 3. So what we just learned here is that absolute value can result in 2 answers, because you have to move to the left and you'll be that distance away from 0, and you can move to the right and be another distance away from 0. So I hope that clarified for you that there can be 2 answers for absolute value. So here we have in example 1, the absolute value of 2x minus 1 equals 9. I want you to figure out, if you can for me, the 2 answers of this equation without me even telling you how to do it algebraically. So I'm hoping that you can look at this equation and mentally plug in values for x and see if you can find the values for x that would make that equation true. And remember, there are 2 of them. So why don't you press the pause key and take a look at that and see if you can figure it out. Now if you thought 5 had possibilities, let's take a look and see if that's true. If I plug 5 in for x and subtract that 1, 10 minus 1 is 9. And I know this is an absolute value when all is said and done, and the absolute value of 9 is 9, so that checked out. Did you come up with the second answer? Did you come up with that negative 4? And the reason why we came up with the negative 4 is because now we want to come up with a value that is a negative 9, because the absolute value of a negative 9 is a positive 9. So that's where it got a little tricky, realizing that you needed a negative 9 in that spot. And there you go. So our 2 answers are going to be 5 and 4. Negative 4. Now, we don't want to sit there and analyze the equation and think mentally what the x value would be, especially when the equations get a little trickier. So what's an easy way to do this? Well, I'm going to tell you. I'm going to clear what I have on the side there and give you a clean slate to look at, because I want you to write these steps. The first thing you want to do is set up 2 equations. So first, let's set up 2 equations. And the first equation is going to be the positive side. Remember how we have to do the positive and the negative in our prerequisite that we just looked at? So you just set up 2x minus 1 equals 9, and the absolute value bars can go away because we're going to set up 2 equations. So the second step we're going to do is set up a negative 9. So we have 1 positive and then we'll have one that is negative. Notice what's positive and what's negative though. It's the thing that we are setting off against. So the 9 is what takes on the negative and the positive role. Did you hear me say that? I said the 9 is what takes on the negative and the positive role. So many times I have students who want to make this the positive and the negative. No, 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 that's not what we do. So make sure you were following my directions, and whatever the equation is set off against, that's what you make negative and that's what you make positive. From there, it's a piece of cake. We just have to walk through the Algebra 1 skills we have and find out that there we are. There's that 5 we already anticipated. And what do you think this one's going to come out to be? We said 5 and -4, right? So this answer should come out to be a -4 if we mentally did those correct. And there it is. Those are our two answers. So x could equal a -4 and 5. If you'd like, you can write them on one line. If you want to keep them separate, that's okay. All right, now it's time for you to try. Go ahead and do this you try. Write it down in your notes. Give it a try. When you're all finished, press the pause key, come on back, and I'll reveal the answer for you. So welcome back. Your answer is -2 and 3. How'd you do? Hope you got those. This next example is going to deal with inequalities. In particular, we're going to start with the less than, and I'm going to reflect back on what you learned in the previous lesson, which is that less thans are and statements, and statements have a number in front, a number in the back, with the variable wedged in between. The other thing that we learned that we're going to incorporate is the fact that absolute value is a distance from 0. So I'm wondering if you can figure out, in order for us to remove these absolute value bars, we have to create both a positive and a negative aspect to this inequality. So how can we go ahead and do that in this particular problem? So if I want to get rid of these absolute value bars, I can write 2x plus 7 is less than 11, and that's a positive 11, right? So what else do I have to do? Now I've got to wedge that variable in between something, so I'm going to put an inequality less than sign in front of that 2x, and what number do you think would have to go in this box here? The -11. So keeping in the same format that we just did in our previous example, I'm going to set up a negative and a positive because I'm in absolute value. Whenever you're in absolute value, that's what you're going to do. Now it's a piece of cake. All we have to do is work from the inside out, follow all the rules of our basic algebra, and we get -18 is less than 2x, which is less than 4. Divide out that 2. And divide it to everything. The -18 now becomes a -9. We have the x and the 2. If we were asked to graph this, then we would have to put an open circle at the -9, an open circle at the 2, and since it's wedged, it would mean all values in between. So this is our mathematical sentence. We would leave it like this. That's our answer. And this is what our graph would look like. Now it's time for you to try. Here is your next problem. You have the absolute value of -x plus 5 is less than 6. Go ahead and give that a try. When you're finished, press the pause key and I will have the answer for you. Welcome back. So here's your answer. The answer is -1 is less than x, which is less than 11. You had to do some switching of the signs there, and if you graph it, it's an open circle between -1 and 11. If you have any questions on how this played out, feel free to ask us questions, and we will be happy to answer them in class. Moving on now to the absolute value of inequalities with the greater than sign. Let's continue to incorporate what we already know, which is the fact that if we're in a greater than, that means we're in an or statement. So we already know that we're going to take this situation and we're going to put an or sign in between the two inequalities that we create. Now, as always, we're going to create a positive side and we're going to create a negative side. We've been doing that the entire lesson so far. We're not going to change that theory. We're going to keep working with the idea of the distance from zero, and that's the positive distance from zero. And now on the negative, it's pretty easy with one exception, and I want you to make sure you're paying attention right now. We do indeed have that -7, but watch what's going to happen here. We're going to take that inequality that's greater than and we're going to make it a less than. So we have two changes, and they are the fact that we have a less than and the 7 that was positive is now negative. Okay, so now we're going to just go ahead and compute these two inequalities. We have a -3x is greater than a -3. Dividing out that -3, we have x is greater than, oh, we've got to change the sign, almost missed that. Because we're dividing by a negative, we're going to switch the inequality sign. We're going to switch it to a less than, and it's going to be less than 1. Remember that we have to include or in our answer, so I'm going to make sure I write that before I forget. Then I'll go over to the right here and I'll finish off the second part. And we have a -3x is less than a -17. Dividing out the -3 causes us to flip that inequality sign again, and we have x is greater than 17/3. If we were asked to graph that, we would split the graph this time, and we would have an open circle with all the values going to the left, 4, 1, and then we'd have an open circle on this side at 17/3, and we would have all the values going to the right. So this is our answer for this problem. If you have any questions, you have opportunities to ask in class. In the meantime, I'd like you to do the U-try and see if you have some idea of what we're doing with inequalities with greater than. Here's your U-try. You have the absolute value of 3x minus 2 is greater than 8. Go ahead and figure that out. Press the pause key while you're working, and when you're ready, come on back and I will have the answer revealed for you. Okay, if you got the answer of x is less than -2 or x is greater than 10/3, you did a great job. Open circle, because we do not have the or equal sign in this problem. It's time to wrap up what we learned today. We learned that the absolute value is the distance from zero, leaving us the possibility for two answers. However, I do want to point out right now something I have not mentioned before, that if your inequality or your equation even is set to 0, you would only have one answer, and here's why. Let's take a look at that quickly. If I have, let's say, x plus 4 is less than 0, you can see that I don't have the ability to make 0 positive or negative. Therefore, I'm only going to get one answer. I thought that was pretty cool to show you. And finally, in our next wrap up, I wanted to just spell out for you very clearly that less thans are and statements. They are wedged between two numbers. You're going to start off by seeing it this way, and then you're going to write it in this format, and then this would obviously be your graph. Okay? And in our greater than situation, it's an or statement, split graph. Here's how it would start. This is how you would write it down here. That would be how we would write it, and this would be our graph. All right, well, that does it for today, and we'll see you soon.